Rather than doing your warm-up in your composition book, today you will be doing your warm-up on page 333 using the number lines provided. Your goal is to place the square root of 4, square root of 64, square root of 9, and square root of 1 on the number line accordingly. Here it says find the exact length of the triangle's hypotenuse. Keep in mind we are using a squared plus b squared equals c squared. Also known as the Pythagorean theorem. So we will do 1 squared, which is 1, plus 1 squared, which is 1, and that is going to equal c squared. One plus 1 is 2, so c squared is 2. That means c will be the square root of 2. We're square rooting both sides. We square root this and it leaves us with c, and square root of 2 is exactly square root of 2. Then it says, what do you think the approximate length of the hypotenuse is? The square root of 2 falls between 1, because 1 squared is 1, and 2, because 2 squared is 4. About how long is the square root of 2? Can you find a number we can square to get the square root of 2? So we're going to slide this along here, and if you click on hypotenuse it, it's going to drag out to that side length. So we're trying to get it filled in as close as possible. And if you zoom in here, you can see it goes beyond at 1.5, but not quite far enough at 1. So it says, how would you improve this approximation of the value of the square root of 2? Instead of counting by halves, we could count up on our number line by 0.1 or smaller. So here it says, can you narrow down where the value of the square root of 2 should go on the number line? Use the squaring calculator to help you decide. So we already know that it's between 1 and 2, and you can click submit and then continue, and it'll show you here's this 1 and here is 2. So if we type in here 1 squared is 1 and 2 squared is 4, so it has to be between those. So if I click continue, it's going to zoom in between 1 and 2. So if I click over here and submit, it should show me between the values that I placed my bars on down here. But I need one that's below and one that's above, so I have to go back and adjust. Now we're going to try that. They're both still too low, so we're going to go back and adjust again. That looks close, so I'm going to check. 1.3 is 1.69, and 1.4 is 1.96. So both of those are actually still below. So I'm going to scoot it up one. And now you can see I have one that's slightly below and one that's above. So now I'm going to zoom in between 1.4 and 1.5. Both of those are too short. That appears to have one below and one above, so I'm going to try for 1, and it's going to zoom in. Now I'm between 1.41 and 1.42. You can see those are both too short. So go back and increase it. These are still both too short. Increase it again. Still too short. And then I have one that's below and one that's above. So that was 1.414. All right, so we now know it's between 1.414 and 1.415. And we can't continue past that, but this process would continue on, but we are going to approximate to 3 decimals. Here it says, approximate the value of the square root of 2 by rounding to the nearest place given. So for the nearest tenths, this would be closest to 1.4. For the hundredths, 1.41. And for the thousands, 1.414. For this one, we would have 4 squared is 16, plus 4 squared is 16. 16 plus 16 is 32, which is not a perfect square, so we write it as the square root of 32. So I know that 5 squared is 25, and 6 squared is 36. So 32 is between 25 and 36. And we have one shorter and one longer, so we can continue. I'm going to make an approximation, and then just a guess and check. Looks like they're both too short, so I'm going to have to go back and adjust. Let's try this one. Still both too short, so bump it up. And we have one short and one long, so we can continue to zoom in. These are both too short, so I need to adjust higher. And then I have one that's too short and one that's too long, so I can keep going. Zooming in. Those are both too short, so I need to move up on the number line. Still too short. And then I have one that's too short and one that's too long, so this is correct, meaning that it's between 5.656 and 5.657. So the tens place, if we were rounding to the tenths place, the 5 would make these both go up. So we're going to round to 5.7. If we're rounding to the hundredths place, the 6 and the 7 would both make the 5 go up to a 6. We don't know what the next place value is going to be, so I don't know if it's closer to 6 or to 7. If it was like 6, 4, then it would stay a 6, but if it's 6, 5, it would round up to a 7. So we don't actually know which of these it would be. But for the sake of our approximations, we're going to just use the smaller one, just because we don't quite know. Here I have a cube. This is a cube, so its edge lengths are equal, meaning the base, the height, and the width are all the same size. What is the edge length of the cube, and how do you know? Well, I know that 2 times 2 times 2 is 8. So the length of the edge is 2 units, because 2 times 2 times 2 is equal to 8. So you can see here 2 cubed is 8. Or you can think of it as the cubed root of 8 is 2. So instead of a square root, when we have values that are cubed, we used what's called a cubed root. The volume of this cube is 18 cubic units. How would you find the length of its edges? I would use the cube root of 18. And so in here, let's see if there is so this is a square root. We need a cube root. This is the symbol that we want. We're going to put a 3 in this little box, so it's a cubed root, and then we're going to put 18 on the inside. Can you narrow down where the value of the cubed root of 18 should go on the number line? Use the cubing calculator to help you decide. So I know 2 cubed is 8, 3 cubed, 3 times 3 is 9, times 3 is 27. So 18 is between 8 and 27. And you can see I have one cube that's too small and one that's too big, so I'm going to continue. Now we're approximating. We're looking for one cube that's smaller and one cube that is larger. Looks like both of these are still smaller, so we need to go back and adjust higher on our number line. These also look smaller, so we're going to go back and keep going larger. You can see I have one inside and one outside, so I can continue. It looks like both of these are still inside, so we need to adjust to make them larger. And then I have one inside and one outside. So we can continue. Those are both too big, so we need to go back and adjust lower. Again, I have too big, so it needs to go lower. These are still too big, so it needs to be lower. And then I have one inside and one outside. So it is between 2.620 and 2.621. So rounding to the tenths, the 2 lets the 6 stay. To the hundredths, a 0 and a 1 both keep it at 2.62. And then again, we're not sure what the next place value would be, if it would round it up to a 1 or if it would stay at a 2, but we are going to approximate too low, so that way if we need to adjust accordingly, we can. In this one, we are looking to approximate the value of pi. Here you can unwrap the circle. And then it says, lock it in. Are the circumference of the circle and the sides of the square related? How? Well, if the circumference of the circle was 2 pi, there would be pi, and there would be another pi. So are the circumference of the circle and the sides of the square related? The side length of the square is pi. 1 pi, 2 pi. How can you find the area of the square? We can multiply pi by pi. If you want to, you can click in here and use the pi symbol instead of pi for pi. Or pi times pi is just pi squared. Right? Base times height, pi times pi. Or in a square would be the side length squared. Okay, so we are now approximating the area of this square using pi squared. Well, we know pi is about 3, and 3 times 3 would be 9. So I'm going to jump in over here. Oh, but it says, can you narrow down where the value of pi should go? Not for the area of the square, so should be between 3 and 4. And you can see here, 1 below and 1 above. You said that the value of pi is between 3 and 4. What does that mean about the value of pi squared? 3 squared is 9, and 4 squared is 16. Therefore, pi squared should be between 9 and 16. What whole number do you think pi squared is closest to? 3.14 is our typical approximation for pi. 3.14 is closer to 3 than it is to 4. So I'm going to assume that pi squared is closer to 9 than it is to 16. And my guess is that it's around 10. So here, can you narrow down where the value of pi should go on the number line? Keep track of your approximations. So we have it's between 3 and 4. We have one below and one above, so we're going to continue to zoom in. It's between 3.1 and 3.2. We know it's around 3.14. You can see I have one below and one above. So I'm going to continue. Again, I have one below and one above. So it is between 3.141 and 3.142. So for the squared value, we would type in 3.141, and that tells us 9.865881. And we're going to change that to our over approximation, and that says it's between 9.865 and 9.872164. All right, approximate the value of pi squared by rounding to the nearest places given. The tenths. The 6 would round this up to a 9. The 7 would round that up to a 9. So it's around 9.9. Hundredths. The 5 rounds that 6 up to a 7. The 2 keeps it at a 7, so 9.87. Thousandths. The 8 would make this say 866. And then this one would say 872. But again, we don't know, so I'm going to use the lower end because I can always make it higher. All right, your guess from earlier was that pi squared was about 10. My current approximation says pi squared is about 9.9. What do you notice and what do you wonder? I wonder how far I could continue to approximate pi squared using the above and below strategy. I need one that was within the box and one that was outside of the box to continue to narrow it down. Please make sure that your warm-ups are completed and any notes that you need to are filled in your workbook for this digital lesson.